Okay, so let's look at number 3 here. So we've got a plane that's parallel to the xy plane and intersects the z-axis at a certain point, and we want to know if the following vectors are parallel to this plane or not. Now, of course, so where it intersects the z-axis doesn't matter because we're just talking about vectors being parallel. So we're going to draw the picture here, and our there's a particular convenience about this particular plane that's going to allow us to make better sense out of this problem. Here's our plane. It's parallel to the xy plane. This is x, this is y. So in particular, it's horizontal. Right? And now one of the vectors that we had, let's look at the first vector, 7, 3, 4. So that first vector is like, I don't know, like that. Now it's tempting to say that 7, 3, 4, you're like, oh, hey, 4. Well, that was 4. This is a 4. Hey, that's that point is in the plane, but that's not parallel, right? What we're looking for is vectors that are like this plane, parallel to the xy plane. In other words, horizontal. So specifically, any vector that's horizontal.
Yeah, I mean, you can show that easily for this problem because this particular plane is horizontal to xy plane.
Yeah, that's right. In general, it's more difficult, and we'll talk about that in section 1.5.
That's what I was asking. If you put the tail of the vector in the plane,
then you would need the head to also be in the plane. That's right. But that's not really the technique that we're going to do in the future. It turns out there's a much better way. It's very slick that we'll talk about in section 1.5. Yep. So for this problem, again, you're right. I mean, this is a lucky break, and it's the solution here is peculiar to this particular problem. The solution is to observe that all these vectors are something, comma, 0. And so of the 3 options, we have number 1, not parallel, because that's not 0. Number 2 is 980. That's 0 in the 3rd position, horizontal. Therefore, it's parallel to this plane, and number 3 is not. Yeah, exactly.